In this question, we will solve mathematical and real-life problems on related rates. It's from the lesson 4.8. Here we have a real-life problem. Suppose a 6 feet tall person is 12 feet away from a 18 feet lamppost. You can see over here in this figure. The first question is, if the person is moving away from the lamppost, that's this right side, at the rate of 2 feet per second. So it's along the horizontal axis. dx by dt with respect to time is 2 feet per second. So it should be second here. At what rate is the length of the shadow changing? This is the length of the shadow. See over here, the s value. We have to find ds by dt. What is that? And the part B will do it later. So what is given? Since it's the writing part, let's write given. We have dx by dt. This can also be written as x dash or x prime of t with respect to time, because everything is changing with respect to time. His movement is with respect to time, it changes this distance, and the shadow also changes with respect to time. That's why we write over here with respect to time, that's bracket t, or dx by dt. That is given as plus 2 feet per second. We need to find ds by dt, or you can write it as s prime of t. That's the thing. And what do we know? Now the solution. Here, if you look carefully, this is like this similar triangles. There are two triangles inside. The angles will be same, and this is 90 degrees, so this is a similar triangle. And we can use the relationship of similar triangles. What is the bigger triangle, outside triangle? It's x and s, isn't it? So we can write x plus s this side divided by, what is this, 18 divided by 18. That will be equal to the inner triangle, that's s, divided by, what is this height, is 6 feet also, it's 6 feet divided by 6. Now we will simplify 6 1 times and 3 times, and let's multiply this 3 to the other side. It'll be x plus s is equal to 3 times s. Take this s to the other side, it'll be x is equal to 3s minus s is 2s. But now we do not want these values, we have to find the derivative, okay, differentiation, because we have the value of dx by dt and we have to find ds by dt. So let's do implicit differentiation on both this side with respect to time. Let me just write it over here. X is equal to 2s, isn't it? Now let me derive this side, dx with respect to time dt, that is equal to, see, what is the derivative of x with respect to x? It'll be 1. But with respect to time, it will be, this is basically dx by dx, that is equal to 1. But here now, d by dx is not there, it's with respect to time. So we just write it like that, or x prime with respect to time. This is how we write it. So here dx by dt is equal to 2 times. Now ds by dt, that is the shadow changing. Take the 2 to the other side, it will be half of dx by dt is equal to ds by dt. Now what is dx by dt? We have the value, it's 2, that's half times 2 is equal to the rate of change of the shadow. That is dt cancels off, your answer is 1 is equal to ds by dt. That is the rate at which the shadow is changing. It's 1 feet per second. That's increasing. Why? Because he is going towards the right direction, right side. Now the second part is repeat with the person 6 feet away from the lamp post and walking towards the post, towards this lamp post at the rate of 3 feet. I'll write it as x prime of t. It's the same thing, but it's minus this time. Why is that so? Because it's coming towards it, so 3 feet per second. So it's negative. Here it's the same situation. All we need to do over here is this part. I'll just change that one only. The new value is half times minus 3 is equal to ds by dt. So here it will be negative 1.5 feet per second. That is the rate of change of the shadow for the second case. Why? Because they have told is coming towards. So that must be the answer. Let's look into the answers. Now here the answers are wrong because they have chosen some different values altogether. The given value is not 2, it's considered to be 0.5 here, and next one it's considered to be -1. But the other methods are same. You can refer this till over here. It's just that the given value is considered to be erroneous over here. That's the reason we get the wrong answers. I hope it's clear. But whatever I had written over here is absolutely right. So just follow this and that'll be more than enough. We'll move on to the next problem. In this problem, we have been told Boyle's law for a gas at constant temperature is PV is equal to C, where P is the pressure, V is the volume, and C is the constant. Assume that both P and V are functions of time. Show that P prime with respect to time divided by V prime with respect to time is equal to minus C by V squared. Basically, we have to just find the derivative over here. So what we'll do is P times V, that is equal to C, right? We'll derive this on both the sides. Here, remember, we have to use the product rule. If you have A and B, that product of the whole derivative, when we derive this, it's going to be A prime B plus AB prime. So here it's going to be P prime with respect to time times V plus V prime with respect to T times, this is going to remain as it is P over here. That is equal to, what's the derivative of a constant? It's 0. It can be any number, it'll just be 0. Now we'll divide everything throughout by V prime. Why? Because we need P prime divided by V prime, isn't it? V prime of T. Now that is obtained over here, and V prime of T here would cancel. And there's no point dividing anything 0 by anything. It'll be 0 itself. So I'm not going to write it. Even if you write it, it'll be 0. Let me write it. And this still will be 0 itself over here. Okay, this part. Now what next? We have P here. So I'll take this P to the other side. So it's going to be V prime of T divided by V prime of T times V is equal to minus P. See, look, this is only P remaining because this is cancelled off and it's 0. When it moves to the other side, it'll be minus P. And then let's take V to the other side. P prime of T divided by V prime of T is equal to minus P divided by V. But look at the question. They have asked us minus C by V squared. What we do is look at the given equation. Let's rearrange and see what is P, because there's no P involved at the right side. So P is equal to C divided by V, isn't it? So I'll just substitute that over here. Minus remains P is C by V, and we already have a V at the bottom, so it's going to be 2 V's. Or it'll be minus C by V squared. Now look at this. Yes, that's the correct answer. The second question is to solve for P as a function of V. Okay, this given question now we should not do this implicit differentiation. What was this exactly with respect to time, right? dP by dt. This is implicit, and then we add dV by dt. That is prime V prime or P prime. This was implicit differentiation, but now we are doing derivation with respect to V, the other term. Treating V as an independent variable, compute V prime of V, compare P prime of V and this particular equation. Okay, so I'll just clear this all off. And now let me solve the second part. The given equation is PV is equal to C. What I'll do is I'll just take it to the other side. So it'll be P is equal to C by V. And now let me derive both the sides. Here on the left side, it's going to be P prime with respect to volume. So that is V. And over here, we are deriving with respect to V. So imagine if it was Cx or constant 2x, 2 by x. We'll write minus 2 by x squared, isn't it? Because when we bring this up, it will be minus 1, then minus comes down, and x power minus 2, we take it down. Same way, I'll directly write minus c by v power 2. Okay, did we finish it? Yeah, we have done derivation. And then you do not need to write dv by dv, because we're doing with respect to v, it's 1. So we don't need to write that at all. So here, that will be the answer. Let's look at the question. We are compared with part A. They are the same thing. Can you see that? They are same. So that is what it says. So P prime of t divided by V prime of t was equal to minus C by V squared. And the same thing is obtained when we derive the given equation with respect to volume as well. So as you can see, that's the thing. It's the same. The next question is about a real world problem here, but there's no figure given. So let's draw a figure. A dock is 6 feet above water. Suppose you stand on the edge of a dock and pull a rope attached to a boat at a constant rate of 2 feet per second. So there is water here, this is the ocean. There's a dock. Imagine this is the dock. And we are at the edge of the dock, somewhere over here. And we are pulling a boat. So imagine it's something like this. You're pulling this boat over here. The boat is something like this. Just imagine that's a boat. Some things, and yeah. And now, what did they give us? They have told pull a rope attached to it at the rate. See, this is being pulled. Imagine this is the rope. We can take it as R. The rate is given. See, feet per second. R is this. What about this? This is the X value, the horizontal distance. Let's take it as X. And this height is told as 6 feet. They've mentioned it. It's 6 feet. And over here, this is being pulled. The boat is being pulled. This is a very bad way of drawing a boat. But anyways, and assume that the boat remains at water level. So this is going to be at the water level over here itself. I mean, it's going to move, but it's going to be at the water level. At what speed is the boat approaching the dock when it is 20 feet from the dock? So this X value is being told to be 20 feet. And also another question, 10 feet from the dock, somewhere over here, when it reaches, what will happen? Isn't it surprising that the boat speed is not constant? Let's solve it and then we will check it out. So here we have Pythagoras theorem. Because this is 90 degrees, we can use Pythagoras theorem here. That's going to be r squared is equal to 6 squared plus x squared. Now what we exactly want, we have been given the constant rate over here. We have been given dr by dt with respect to time, because feet per second, so it should be divided by time. That is given as 2, but it's pulled, it's coming towards the left side, so it's minus 2 feet per second. That is given. And they have also given us the x values. So x values at 20 feet, 20 and 10. X is equal to 20 and 10. Now let's derive here both the sides. It's going to be 2 times r times dr by dt with respect to time. That is equal to the differentiation of any number. 6 squared is 36, but it's going to be 0 when you derive it. 0 plus 2x times, not again 2x, it's 2x times x dx by dt. Now we have this information. What do they want exactly? They want us to know at what speed the boat is approaching when the dock is. So this is what they want. The rate of change of the left, the distance, that's speed. So here we have 2r into dr by dt, isn't it? So let's substitute what we know. But before that, let's simplify how much we can. See, this 2 and 2 is 0, so it's 2r dr by dt. That is equal to 2x dx by dt. This cancels off. Now what about r? What is the value of r? Look, we know x value, that is 20, but we don't know r at all. You can find r by substituting the x value, but better than that, how about we write this r in terms of x and this value? So it's already written over here. So what is r? R will be equal to square root of 36 plus x squared. So I'm going to write that over here. Square root 36 plus x squared dr by dt. That is equal to, now here x, I'll take it to the other side. I'll write it as divided by x is equal to dx by dt. So this is what we had to solve. Now just solve for two cases at x is equal to say 20, and you should solve it at x is equal to 10. We can just use our calculators and do it. Let me show you. Let's write this equation out. It's square root 36 plus x squared divided by x. And here, why I wrote this? Because we have two values to check, right? What is dr times dr by dt? It is times minus 2. I had to write this. I've forgotten to write it. Let me write it below. It's square root 36 plus x squared divided by x. Dr by dt is minus 2. That is equal to dx by dt. That's basically x prime of t, and r by dt would be r prime of t. Now here calculate this firstly at 20. So what's the answer? It's minus 0.208. What's the next answer? Calculating at 10. Shift and solve. See, this is bigger. And it makes sense. It's 10, right? See, as the boat is moving, initially, if there is some rate of change and it's going closer and closer, it increases the speed. It increases the rate of change in the horizontal axis. That's the reason. So yeah, these two were the answers. It's negative because it's coming closer. See, this boat is moving towards the dock. And here we are getting a 20x is minus 2.088, and here minus 2.332. The next question is another real world problem. Here the sand is poured into a conical pipe with the height of the pile equaling the diameter of the pile. What this means is height is equal to diameter. If the sand is poured at a constant rate of 5 meter cube per second, meter cube, its volume, by second, its derivative of the volume with respect to time, not second, sorry, not ds, it's dt with respect to time. Or you can write v prime with respect to time. That is 5 meter cube per second. At what rate is the height of the pile increasing? At what rate the height, that is dh by dt, as you know, you keep on pouring the sand in a conical. Imagine this is the cone. You're pouring the sand at this particular rate, 5 meter cube per second. You know, the sand is being a pile. It's increasing in radius. It's increasing in the height as well. So what rate will the rate of change of height of the pile increase when the height is already 2 meters, when it reaches 2 meters? H is 2. Now let's see which formula to use. We have to use volume of a cone because they've told clearly a conical pipe. So V is equal to 1/3. Cone is always 1/3 pi r h squared. But here they have told, sorry, it's not h squared, r squared h, I believe. So it's 1/3 pi r squared. Yeah, that's the formula. H is not squared. I was just confused. Okay. So now here, do we have RH? No, but we have a relationship of H is equal to D. That means H is equal to 2 times R. Why do we write this? Because diameter is 2 times radius, isn't it? Now let us write R in terms of H because we need H, not R. So I'll try to remove this R altogether. So I'll take this 2 to the other side. It will be H by 2 is equal to the radius. So the radius is half the height. Let's substitute everything over here. V is equal to 1 by 3 pi. R is basically h by 2 squared by h. Now let's square this up. It'll be 1/3 pi h squared by 4 h volume. Now I will simplify this. 3 times 4 is 12, 1 by 12 pi, so I'll write pi by 12, h times h squared times h is h cube. So this is the reduced form of the equation. Now what I do, I have to just, derive both the sides, implicit differentiation, what we have done before. So it'll be dv by dt, here it is just v dash, that's it, nothing else, is equal to pi by 12. This is constant, but here when you derive it will be 3h squared multiplied by dh by dt. So this is the derivation, implicit differentiation with respect to time. Now, what do we know? We have to find what is the rate of change of height, that is dh by dt, at 2 meters. And we know what is dv also. So phi is equal to pi by 12 times 3 into 2 the whole square into dh by dt is unknown. So just put this in the calculator and you can solve it up. We'll just take it to the other sides. Simplify how much you can. Here it is, how much is this? It's 2 squared, 4 times 3 is 12, and this cancels off with this. So just pi goes to the other side. So dh by dt will be equal to phi divided by pi. You can just put that in the calculator and you'll get the final answer. So it's phi divided by pi. Just press equal to, or if it is in fraction again, just press shift SD, sorry, not shift, SD, you'll get the answer. It's 1.59. Now that is in terms of meter per second, is equal to 1.59 meter per second. That is the rate of change of height with respect to time. So let's just look into the answer. Here they have just written in phi by pi. That is absolutely fine. We can even put in the calculator and find this value as well. So it is pretty simple. I remember 2 years ago this had come for the final exam, during the exam for the grade 12. So what we need to do over here is first write the conical, it's conical shape. So cone's volume is given by V is equal to 1/3 pi r square h. You need to remember the formula because it's not given here. And then we just do the substitutions. What is known? R is equal to h by 2, and then square it up and you rearrange the term. It will be V is equal to pi by 12 h cube. You do implicit differentiation with respect to the time. It will be dv by dt. Here it's going to be 3 times h square and dh by dt. Then all you do is substitute what is known. We know dv by dt, we know h is 2 given in the question. And then we can just put in the calculator and get the answer. Let's look at the next problem. This problem is a very huge problem. Let us see what is exactly required. Over here at the last thing they have told, find f derivative of t. For this function we have to just derive. They have given you what are the terms. So I'm not going to read it. You can pause the video and read it entirely. It's about a guitarist and the frequency depends on the L, that is the effective length in the guitar, and square root of T, that is tension, divided by rho. This is called as rho, the symbol. It's usually used for density. Now what we do is we will write the given function 1 by 2L square root T by rho. Let's substitute what is known. They have told suppose L is half. So here 1 by 2 times half. So this cancels off. And what is the square root of T by rho? That entire thing is 220 multiplied by 220. So what is the frequency? This is 1 times 220 is 220 itself. 220 hertz is the frequency. Frequency is given by hertz. Cycles per second. Now this is just f value. What is the derivative? Let's do the derivative. F derivative would be, now let us keep the same thing before that. Before doing the derivative, let me write f is equal to 1 by 2L square root T by rho. Here look carefully, they have given us L dash. So what I'll do is I'll just substitute this one. I'm not going to substitute L because I need to find L dash, isn't it? So what is this value here? Because I do not know these values over here. So 1 by 2L times 220. And this cancels off. One time it's 110. So F is equal to 110 by L. So how can I derive? Just derive with respect to this time, f prime of t. That means df by dt is equal to this one, 100. 100 is a constant. What is the derivative of 1 by x? Do we minus 1 by x squared, right? But since we are doing implicitly, then we have to write x prime as well. Again, whatever is there with respect to whatever we are doing. So it's a 110, but it'll be minus divided by L squared. How we do it is this goes up, it'll be negative power, and this is how we solve that. But don't forget dl by dt. Now then we can substitute what is known. What exactly do we know? We know the L value, we know the dl by dt value is minus 4. So let's substitute everything. Minus 110 divided by this half, the whole squared, multiplied by minus 4. That is the derivative that is given as f prime of t with respect to time. Okay, let's put this in the calculator and check what will be the answer. All you need to do is substitute this. Let's use the fraction. Minus 110 divided by, use the brackets, it's 1 by 2, 1 divided by 2, or you can write 0.5, it's easier. Square it up, multiplied with minus 4. You can use bracket whenever there is minus sign, so I'll just use the brackets here. So that's the answer. It's 1760. You can see here the answer must be 1760 cycles. That's the derivative, cycles per second. Now here they have also told at what rate will it take to rise the pitch 1 octave, that's double it off. Here what they do is, all you need to do is the cycles divided by this. So all you do is f of t divided by f prime of t, and you would get 220 divided by 1760, that will be 1/8. Now what happens here? It's cycle per second, and this is cycles. Alright, cycle per second. This is cycle per second because we're deriving. It's cycle per second squared. So not squared, per second. So this cancels and this goes up, so it'll be 1/8 of a second. Because it's in the denominator's denominator, it'll go up. So that'll be the answer. We'll move on to the next problem. Suppose that you're blowing up a balloon by adding air at the rate of 1 feet cube per second. If the balloon maintains a spherical shape, sphere this is, the volume of the radius are related by, volume is equal to 4 by 3 pi r cube. This is the sphere formula. Compare the rate at which the radius is changing at these two radiuses 0.01 and 0.1 feet. Discuss how this matches the experience of a person blowing up a balloon. We have been told the formula. Let's use this formula. Volume is given as 4 by 3 pi r cubed. All we have to do is we need to derive it. There's only volume and there's radius. They have told the rate at which adding the air. Adding air is in the sense volume. This is rate of change of volume because feet cube is volume. So that is dV by dt with respect to time. What we need is the rate of change of radius changing. dr by dt is required. So I'm going to just derive this dV by dt. That is equal to 4 by 3 pi. 4 pi by 3. I just write it like this. What happens here? 3 times r squared times dr by dt. Because it's implicit differentiation. Now then, what is dV by dt? It's 1 is equal to 4 pi by 3. And this, I just simplify here. 3 cancels. 4 pi r squared and dr by dt. We need to find dr by dt. So I'll leave this over here and everything to the other side. So 1 divided by 4 pi r squared is equal to dr by dt. Now then, what is the radius given? First case, at r is equal to 0.01, what happens is dr, the rate of change of radius with respect to time, that is also given as r prime with respect to time, can be written as 1 by 4 pi r square, right? I'll write it as 0.01 the whole square. You can directly find it over here. And the second case, the first case, the second case at 0.r equals 0.1. What happens here? It's in terms of feet. So it'll be feet per second here. Whatever the answer is there, it'll be feet per second. Remember the units are important and it's writing exam. So please make sure you write the units. Here it's dr by dt, or we can also write it as r prime of t, that is equal to 1 divided by 4 pi. This is constant, but what is r? It's 0.1 squared. So remember, it's 0.1 squared. Don't forget the square. As it is over here, whatever we written, r values are given. There are two different r values. So what is that? It'll also be in terms of feet per second. You just put these values in the calculator and you can find it out. Here we have 1 divided by 4 pi is by shift and the symbol here into 0. I'll just use the brackets 0.01, close the bracket and then square it up. Here you can see it's 795.77. The rate of change is very much high, you can say. It's a huge value, isn't it? So here it's 795.77 feet per second. What about the next case? Only it is, remove the 0 off, and it's 7.95 or 7.96 feet per second square. Why is there so much difference? Look, when you initially blow air into the balloon, it's just a small balloon, right? It'll it'll be big very easily, very quickly it'll gain the radius. So the rate of change of radius when the initial radius is such a small thing is more, it's always high. But as you go bigger and bigger, the rate of change of radius is low because it has already taken much volume. So if you practically think about it, when a balloon is so small, when you just blow maybe 1 or 2 times, it'll become so big. But then if you just put 1 or 2 times, it'll just increase a little bit. So that's why as the balloon gets bigger, the rate of change of volume, rate of change of radius reduces, and that is what has been visible. That is the explanation. So you can just write over here, discuss how this matches with the experience of a person blowing up the balloon. I'll just write it out. When the balloon is smaller, the rate of change of, I'll just write dr by dt, that is rate of change of radius with respect to time, increases greatly, whereas when the radius increases, the rate of change dr by dt increases steadily or slowly. You can write steadily. This is just to tell what you have understood, just imagine you're blowing a balloon and then you will understand it. So that's the answers. Over here they have written in terms of pi. That's absolutely fine. But it's better to write it in terms of decimal so you'll understand what are the values exactly, and then you can tell it. See, at first radius expands rapidly, later it expands more slowly. Absolutely, that's the same thing, what I told. Now we have a very interesting problem. Water is being pumped into a spherical tank of radius 60 feet at a constant rate given over here. So radius r is given and constant rate is given, that is dv by dt. Find the rate at which the radius of the top level of water tank changes when the tank is half full. So now this is a sphere. Water is being pumped into this. Imagine the water is filled so much. Okay. What is the height? From the center, this will be the height. Not from the center of the sphere. The center of the sphere, this is the radius. This is the radius, right? This height is considered. Now what about this one here? This half of this is basically the radius of the water level. You can take anything. You can take it as x, a, b, c, anything. So this is the given thing. It's a sphere and the water is filled in this. They call this a spherical cap. Whenever we have such case where a sphere is there and water is being filled, and they have told regarding the water radius of the water level, it's not just the sphere formula. It's not what we just used. Let me just show you over here. This is the figure. It is a spherical cap which we need to realize. The formula of the spherical cap is given as here. V equals, it's pi r. So how I remember is V is equal to pi r h squared minus pi by 3 h cubed. It is a simplified form. Otherwise, the pi is written out and 3 is written out and you will have 3r. It's a little bit complicated. This is more easier for me to understand, so I just use this formula. Now, what is given over here? This is the volume, which is pretty simple. R is basically the radius of the sphere. The radius of the sphere, not the volume or anything, not the circle formed by the volume, it's of the sphere. H is the height of the water level. Wherever, how much ever the water is increased, that's the height. Now here, A, which I've considered here, is the radius of the water surface. Now, what exactly do we want? The rate at which the radius of the top level of the water in the tank changes. So it's basically this radius. I'm not going to write r because we already know the radius of the sphere is r. So A is considered. We need A, dA by dt. Or you can consider this to be x. Absolutely fine. Up to you. That rate change with respect to time is required. And they have also told when the tank is half full, that means it must be exactly half full. When the tank is half full means H is equal to how much? Is equal to the radius of the sphere, isn't it? Is equal to the radius of the sphere. And you can go ahead as well. If it's half full, even this is going to be equal to the radius of the water. Then all is given as 60 feet. So this is the concept. Why? Because imagine this is the sphere, it's half full. So that's the radius, this is the radius of the sphere itself. So that is why they all these h, radius of the sphere, and a will be equal. Now how would we solve this? Here we have r, that's the radius of the sphere. We cannot do implicit differentiation with volume, with height and radius. So this is given. Let's substitute and simplify. Volume will be equal to pi times 60. So I'll write it as 60 pi. The constants first, 60 pi h squared minus pi by 3 h cubed. Let me do implicit differentiation over here. It will be dv with respect to time, that is equal to 60 pi times 2h times, don't forget there is dh by dt, minus pi by 3 times 3 h squared dh by dt. Now let's simplify how much we can. dv by dt is equal to 60 times 2 is 120 pi h dh by dt. That minus, this cancels off 3 and 3, so you have pi h squared dh by dt. So what can we find from here? We need dA by dt, but we are getting the rate of change of height. So if we know the rate of change of height, that is important to us. Why? Because look here, I can use Pythagoras theorem and I can relate A and H and radius. So let us find this dH by dt, because there is no other thing which we can solve from here. We can't directly apply the radius of the water. A cannot be applied. So we will solve this. Now dH by dt is there, that can be removed common out, and all the terms here I'll just remove it, take it to the other side. But before that, let me substitute the values, it'll be easier. dV by dt, where is it? This is the dV by dt given, that's 10, that is equal to 120 pi. What is h? H is 60, because h, the height, must be half when the tank is half full. That means it's the radius of the sphere. So this is again 60 dH by dt minus pi into 60 squared dH by dt. I'm just going to take dH by dt, both of this common outside, and whatever is there, we can take it to the denominator. So it's 120 pi times 60 minus pi times 60 squared. Why? Because I've removed these two common outside. You can take it left side or right side, it's the same, dH by dt. Now this entire thing goes down here, 10 divided by 120. So you can just simplify these. So what is 120 times 6, it'll be, I'll just use a calculator here. Here we will just multiply 120 times 60, that is 7,200. And here we have 60 squared, that is 3,600. So 7,200 pi minus 3,600 pi is equal to dH by dt. What happens here? 7,200 minus 3,600 is 10 divided by 3,600 pi. So we'll cancel one of this 0. You will get 1 divided by 360 pi. So this is not the final answer. This is the rate of change of the height with respect to the time. So this is very important. This is basically the first step. I hope this much is clear. 1 by 360 pi gives you the rate of change of the height with respect to the time. How would we find this rate of change of the radius of the surface of the water? Now, if you look carefully, this is the Pythagoras theorem. We can relate it by Pythagoras theorem. This is the hypotenuse r. We have r minus h. See, wherever the height is there, the total will be the radius minus the height. So that's the simple equation which we can relate it. I'm going to erase this. I'm going to remove this all. So please note down these steps. You can pause the video now and you can go through it if you want to go through it again. Now, what is the relationship here? It'll be r squared equals a squared plus r minus h the whole squared. Okay. What do? We'll just use the squared formula. It'll be r squared is equal to a squared plus r squared. Now this is a minus b the whole squared identity. It's a squared minus 2 times ab plus b squared. So r squared minus 2 times rh plus h squared. And now apply what is known. But before that, let's simplify. See, this r squared, when it goes to the other side, becomes minus and goes off. And I will take this, r and h, everything to the other side. So it'll be 2rh minus h squared is equal to a squared. I'm not going to take h to the other side, outside, because it's just going to be more complicated. But what about r value? Radius is 60, isn't it? So it'll be 2 times 60 h minus h squared is equal to a squared. It'll be 120 h minus h squared, that is equal to a squared. Now I have constants and I can just apply the differentiation with respect to time. It'll be 120 dH by dt minus, this is 2h times dH by dt, that is equal to a squared will be over here. Let me just remove this. It'll be 2 times a into dA by dt. Now what is dH by dt? We just did it, right? 1 by 360 pi. So over here I'm going to type out, this is 1 by 360 pi minus 2. What is h now? It's half, isn't it? This is basically at when the tank is half full. That means height will be equal to the radius, so that's going to be 60 over here. Multiplied by, what is dH by dt? It's going to be 1 by 360 pi. That is equal to 2 times 2a dA by dt. Now let's solve this up. Here we have to find dA by dt. 120. Look at this. This is 60 times 2. It's going to be 120 itself. So these both will cancel. It's 120 times 1 by 360 pi minus 60 times 2 is 120. It's 0 here. So I'll just write it out over here. It'll be 0 is equal to 2a. A is also 60 basically. Okay. Why? Because when the tank is half full, the A will be also half the radius. The radius of the water will be equal to radius. It's 60 dA by dt. Or even if you don't substitute, if you just take it to the other side, anything divided by 0 will be 0 itself. This is 0. This goes to the other side, will be 0 divided by 120. It's 0 is equal to dA by dt. And let's analyze this. Is this correct? Say the sphere is there. As you keep on going up, it'll increase. The rate of change of the height with respect to time increases. It keeps on increasing, but the radius also increases. And the sphere is such that it'll be at the center, it'll reach its maximum radius, the surface of the water, maximum. But what happens as we go ahead? It'll start reducing. Why? Because a sphere is such that it'll start reducing. Only at this middle point, if you look carefully, the exact sphere, the middle point, this is maximum. But from here it was increasing, and now this is the midpoint, and then it'll start decreasing. So the derivative at that point, this is the slope, it goes like this and like this. It start decreasing, right? The derivative is 0. And yes, that is true, which we got 0 is correct answer. That is why they have told half full. At half full, it doesn't change. The derivative rate of change of the surface of the water with respect to time must be 0, because after that instant, just after this instant, when it is 61, the height, it starts reducing. This starts reducing the rate of change of the radius, because it is getting smaller and smaller. Only at half, it's the maximum, and therefore the derivative is 0. So this is the way we solve the first problem. So we had got 1 by 360 and then 0. So you can see the solutions. These are the formulas which we use. And over here, we have got the first dH by dt, that is the rate of change of height with respect to time, as 1 by 365 feet per second. Then we can use this value and solve the dA by dt. So now here, they have just rearranged it differently and solved it. You can follow my method, whatever I've done. The answer will be the same. The answer will be 0. You can see over here as well, dA by dt. Finally, when you solve it up, it will be 0 by 60 multiplied by this term. It's 0 itself. Now they have one more part, that's part B. Find the height at which the height of the water in the tank changes at the same rate as the radius. So what they're asking is, the rate of change of the height with respect to time must be equal to the rate of change of the radius, that is dA by dt. When I was trying to solve this by myself, I used Pythagoras theorem and it didn't work. But when I take the height, it'll work. So let me show you how to solve this. What is the radius? The radius is equal to, now imagine this one. Imagine the water is anyway below the radius. We don't exactly know where is the water, right? But we should know wherever the radius and the radius of the water and the height is changing at the same rate. So if that should happen, it must be less than this. Why? Because the height is increasing here, the height keeps on increasing. Now, if you practically think, no matter what, the height will keep on increasing as we go up and up and up. But after the radius, after if it's half full, when the radius is increasing, when the height is increasing, will the radius increase? No, it will become smaller and smaller as the sphere becomes enclosed, right? This will be smaller. So it can't be more than this. It should be less than that. So it should be less than half of the radius. So here, radius, if that's the radius, and height must be less than that, somewhere over here. So the total radius minus h will give you this part. So what I'll do is, the radius is equal to h plus r minus h. Now this is not going to help me, because if I just substitute this, the r cancels, h cancels, it's an identity. But what I can do is, instead of r and h, I know from the Pythagoras theorem, r square is equal to a square plus r minus h the whole square, isn't it? So what is r minus h? Let me just take this a square to the other side. R square minus a square is equal to r minus h the whole square. Take the square root on all the sides, so it will be square root of r square minus a square is equal to r minus h. So I can substitute this over here. Why do we do that? Is because we need dA by dt, that is equal to dH by dt. So that is the condition for us given over here. Now then what I'll do is r is equal to h plus square root r square minus a squared. When we derive over here, let's derive both the sides with respect to time. We will get dr by dt is equal to dh by dt. And then what about this? Here we have a, that is a variable. Though this r is a constant, we have to derive it. So this is going to be 1 by, see what is this? It's half, power half. When we derive half, it will be 1 by 2 times this negative half, and then we take it down. I'll just use the identity. Root x will be equal to 1 by 2 root x. I hope you remember this. I'm just going to use the identity. It'll be r squared minus a squared here. And it's not over the chain rule. Whatever is inside also we have to derive it. What is inside? It's dr by dt. Not dr by dt. We have to derive it properly. This will be 2r times r prime of t. I'm just going to write it. And minus, it will be minus 2a times a prime of t. That is dA by dt. Okay. So that is what's happened. I'll just erase this part up over here because it might be confusing otherwise. So here we go. This is what we have. Now what happens with dr by dt? What exactly is this dr by dt? It is a constant. R is a radius. It doesn't change. It's 60 feet. So this is 0. Derivative of a constant is 0. dh, yes, rate of height is changing with respect to time. This is correct. Let it be dh by dt. What about this? Plus, we have 1 by 2 square root r square minus a square. This entire thing is multiplied with what? Here, this will be, okay, this is again a bracket which I forgot to write. Once we have derived the square root, then whatever is the chain rule is inside a bracket. Now here, this dr, we don't, r is 60, it'll be 2 times, it'll be 120, but the derivative of the radius, constant radius of the sphere is 0. So it's 0 minus 2 times a prime of t, or dA by dH. I'll just, you can write anything anyways. So this is the situation. So now this is 0, this is 0. So let me rewrite it, dH by dt plus, what have we got over here? We will just multiply this, so this cancels off, and what remains is, it is a prime of t divided by square root r square minus a square. I hope this much is clear. So what exactly we want? We know that dH by dt is equal to dA by dt, isn't it? So let me take this to the other side. Okay, this one to the other side. It's a bit clumsy now. It'll be minus. Now this, okay, wait a minute. Now we have a minus over here, isn't it? We already have a minus over here. So when we multiply, it's going to be minus. So I'll just, this is not plus. I forgot to write the minus sign. I'll just remove that to the other side. I'm going to take this to the other side. It's going to be positive. So it's going to be a divided by square root r square minus a square. What is this? dA by dH. dA by dt, not h. So here will be equal to dH by dt is equal to dA by dt. So I'm just going to write the same thing. Because dH by dt and dA by dt are equal. That is what we are solving for, when both the rates are equal. So here let me cancel them off. So what happened? I've got now a, I'll take this to the other side. It's 1 is remaining, so I'll move this to the other side. A is equal to square root r square minus a squared. So here now I'll square on both these sides. It's going to be a squared is equal to r squared minus a squared. Let me take this minus a to the other side. It's going to be a squared plus a squared. It's 2a squared is equal to r squared, or I'll divide both the sides by 2. So I need to rewrite this somewhere over here. I'll just write it. So it's going to be a squared equals r squared by 2. Let me take square root on both the sides. A will be equal to square root of r squared and square root of 2. When we take the square root of r square, it's just going to be r divided by root 2. So this is the simplification. We found the a value when the rate of change of height and the rate of change of radius are equal, we will get r by root 2. Okay, but what do we exactly want? We need to find the height. That's not the a value, the h value we need to find. That is fine. We can easily find it out because we have over here, see, for example, here we have this equation. This equation can be used, or yeah, this only equation can be used because we know all, or we can use one of these equations as well. So what I'm going to do is I'm just going to use this equation and I will find h value. I can just take this to the other side and solve it up. I hope this much is clear. I will now clear all this. You can pause the video and go through it if you want to. So again, how to get that equation? It was r is equal to h plus r minus h. But we know from Pythagoras theorem, r minus h is, here it will become square root r square minus a squared. Now, I can move this to the other side because I want to find only h, right? R minus square root r square minus a square is equal to h. Now I will substitute the a value which we had recently got. So r is equal to square root r square minus, what was the a value we obtained? It was r divided by root 2, the whole square now. That is equal to h. So let me simplify this. R is equal to r square remains minus, let's square both. The top one will be r square divided by root 2 square will be 2. So it will be r square by 2, that is h. Now imagine this is r square is 1 and it will be 1 by 2. What will be x minus x by 2? What is 1 minus half? It's half, right? Even x minus x by 2 is x by 2 itself, half of x. Same way we can write over here, this is r square minus r square by 2 will be r square divided by 2, that is h. Okay, I have done a mistake. For some reason I have made it all equal to here. It's minus. So my bad, this r was minus. I changed it over here by mistakenly and then I forgot. It's minus. R is minus. This is all minus. R minus. Over here we have equals h. So now what? Here let's use the square root. The above term will be r and below term will be root 2. So again, r minus, not equal to, it's minus r divided by root 2 will be equal to h, or we can remove the r outside as common, so it's going to be h will be equal to r into 1 minus 1 by root 2. So this is the answer for h, but we know the radius, right? What is it? 60. So just substitute it. So 60 times 1 minus 1 by root 2 must be equal to the height. So at that particular height, we will have the rate of change of the height of the water and the rate of change of the radius of the water equal. So we used all this, a value, we got the a value in terms of radius. So now we could solve it. Now everything is in terms of radius, and just put this in the calculator. Here then we have 60 times 1 minus 1 by square root 2. So close the brackets, and here we go. The answer is 17.57 feet. Or you can leave it like this in terms of feet, because everything was in feet. So that is the final answer. When the height of the water is 17.57 feet, you can have the rate of change of the radius of the water and the rate of change of height equal. And it makes sense. Why? Because when you come to the half, it's not at all possible. The rate of change will be 0 over here and h will always be increasing. It's not possible more than 60 or above. It should be less than 60. Yeah, it's about right. The 17.57 fits the description. So that is the final answer. I'll just put it back. I hope that's clear. If you have any doubts, please look at these steps. You can write them down. The answer is 17.57 feet. It's been a lengthy problem. I hope this doesn't come for your exam, but This is how we solve this. So we can, okay, the steps are over here. You can just go through these. But whatever I solved is more, okay, they have used some other method altogether. So I would suggest you to stick to with the method which I did because it's much easier to understand and solve. And here the answer will be the same, I believe. So they have used a very tough method. And yeah, that's what we had got. It's 17.58. That's okay. It's almost the same. We move to the last problem in this question. Sand is dumped such that the shape of the sand pile remains a cone. Again, we have a cone shape. Okay. With the width height equal to twice the radius. So here they have told h is equal to 2 times r. If the sand is dumped at a constant rate of 20 feet cube per second, it's dv by dt. Find the rate at which the radius is increasing when the height reaches 6 feet. H is 6. Okay, we know the formula for this, right? Volume of a cone is 1/3 pi r squared h. There is r squared and h. Whereas for the cone, it will just be r cubed. There is no h involved. So how do we solve this? First, substitute what is known. Height is equal to 2 times the radius. So you here, first of all, what is required is if the sand is dumped, find the rate at which the radius is increasing. So we need the dr by dt. So I'm going to remove this h and make it in terms of r. 1/3 pi r square. H is 2 times r. Let me rewrite this. It will be 2 pi by 3. R square times r will be r cubed. Let me derive both the side with respect to time. Here there's only one term, so it's only v, so it will be dv by dt. Here it's going to be 2 pi by 3 r cubed. When you derive, it will be 3r squared times dr by dt. This is what we need to solve. But the problem is the height is given as 6 feet, not the radius. So what is r value? Now we'll use this relation h is equal to 2r. So what is r exactly? It will be h by 2 is equal to r. Let's substitute the 6 feet. So when h is 6 feet, r will be equal to 3. So can I use this 3? Absolutely, I can use this as 3 squared. Let's cancel this off. And dv by dt. Okay, what is dv by dt? I'm going to substitute this value as well. It is 20, that is equal to 2 pi r squared. R is 3, so it will be 9. When you put over here 3 squared, let me write it as 3 squared itself, times dr by dt. So take all these values to the other side and just solve it up. It will be 20 divided by 3 squared is 9. 9 times 2 is 18, so it will be 18 pi. That is equal to the rate of change of radius with respect to time. Just put that in the calculator and you will get the answer. Here we have 20 divided by 18 pi. So the rate of change of radius is 0.35. And here we go. Now they have just written in terms of pi, okay, but they have simplified it. Now wait a minute, they have found out dh and d. You do not need to find dh because they have just told find the rate of change of radius, okay, when the height reaches. You just have to find dr. You don't have to find dh by dt and dr by dt. This is 18. So this can be simplified. 2 table goes, it'll be 10 by 9 pi. That's the answer. You can see dr by dt will be 10 by 9. That's what we also got. There is a part B of the problem. Let's look at this. Repeat for sand pile for which the edge of the sand pile forms an angle of 45 degrees with the horizontal. Now the same question must be repeated. Okay, let's do it again. Let's see what's the figure. It's the cone, and here they have told the, as the sand is being dumped, it's increasing and all that, right? The angle is 45. So here, what happens when it's 45 degrees? Imagine this is the height, this is the radius, right? 90 degree. When you have 45 degrees, this values, they both are equal. Okay, these two values are equal in the sense, if you have, I'll show you in the calculator why it's equal. If you have these two sides, say 3 and 3. So what is tan theta? Tan theta is opposite by adjacent, right? Hypotenuse is not involved. Tan inverse of the same thing. So 3 and 3 is equal to 45 degrees. So that's the reason, you know. Or if you just multiply tan 45 by any of the side, you're going to get the same side. They are equal. So 45 degree means these both are equal here. So that's the thing. So if they both are equal, that is radius and the height is equal. So dr by dt must be equal to dh by dt. So the rates are also equal. That is what it says. Now then we will solve it up. We will use the volume. Volume is 1 by 3 pi r square h. But now I can use it in terms of r or h only. What I'll do over here is 1 by 3 pi instead of r and h. I'm just going to use r cube. Now let me derive both the sides. So why? Because we have to find the radius. Repeat the same problem, right? We have to find the rate of change of radius. So I'm using r. It'll be dv by dt, that is equal to 1/3 pi 3r squared times, here we have dr by dt. And now this 3 and 3 cancels off. Now if you look over here, what is the r value exactly? The radius is not given, but the height is given. Height is 6 feet, and now here we have this new condition. The old condition is gone. It's not equal to twice the radius. Here if h is 6, that is r or h, both of them. So we will just substitute the values here. The rate was 20, not 10. I'm sorry, it's 20 over here. They've given over here the rate of change of volume basically. That is equal to pi r square is 6 squared, and then we have dr by dt. So let's take this to the other side. It'll be 20 divided by pi times, what is 6 squared? It's 36. That is dr by dt. So you can put this in the calculator and simplify, but the 4 table goes. So I'm just going to do 4 5 times is 20, and over here 4 9 times. So 5 by 9 pi is equal to the rate of change of radius with respect to time, or the rate of change of height with respect to time, because both of them are equal. So it should be 5 by 9 pi. So that's the correct answer. So this is the exact method. It's better to do these methods because over here in the solution sets, the methods are not exactly mentioned. That is the end of this question. I hope it is clear. If you have any doubts, please consider rewatching the video or posting your doubts in the comments. I hope you all will head on to the next video.